Okay friends, welcome back. In the previous session, we have seen what is the condition on h of t and h of n if the system is static LTI system. Let's see some more conditions. If a system is a causal LTI system, what is the condition on h of t or h of n? These things we have to see. Causal LTI system. Causal LTI system. So again, I am going for a discrete time case, then we will see analogy between discrete time and continuous time case. Okay. So here, what is a causal system? From the definition of causal system, it should not depend on the future inputs. It is depending only on the present and past, but it should not depend on the future inputs. That's what the meaning of it. So if it is not depending on the future inputs, definitely h of minus 1, h of minus 2 has to be 0. That means if I take h of n, in that for n less than 0, that means for negative values of n, that must be 0. That's what the meaning of it. So I can write like this. For causal system, y of n should not depend on future inputs. Should not depend on future inputs. So if it should not depend on future inputs, from that I can decide h of minus 1, h of minus 2 and so on has to be 0. These things has to be 0. In general, I can write like this. That implies h of n is equal to 0 for n less than 0. For n less than 0. So this is the condition on h of n so that the system becomes causal LTI system. Okay. In the similar manner, similarly, for h of t is equal to 0 for t less than 0. For t less than 0. So this is the condition on h of t so that the system is static LTI system. Okay, take it. Next, what is the condition for stable LTI system? Stable LTI system. Stable LTI system. So we are having the stability, which is nothing but bounded input, bounded output stability. That means if the input x of t is a bounded signal, then output must be bounded signal. Then we can say the system is nothing but stable system. That's what we know. That means, so I can write if mod x of t mathematically bounded means less than or equal to some maximum value and less than infinity. And less than infinity. Then if y of t is also less than or equal to some maximum value n and that value should never be infinity. If these two conditions are satisfied, then we can say the system is stable. Then the system is stable. That's what we can say. Okay. Now consider y of t, which is x of t convolution with h of t. X of t convolution with h of t. So this is can be written as integral minus infinity to infinity x of t minus tau h of tau d tau. I am not making any changes in the h of tau because that's where we have to find out the condition. Okay. So this is what y of t. Now we have to check if a modulus of h of t minus tau. h of t or h of t minus tau, it won't make any difference because shifting and scaling is not going to change the magnitude of the signal. So I can say if I try to find out the magnitude here, suppose if this magnitude is a finite value, then what will happen to mod y of t? Is it a finite value or infinite value? That's what we have to check. So let's see. For that we have to know one inequality which is called as Squarge inequality. You might remember this or you might heard this. Squarge inequality. What is the Squarge inequality says? Suppose if y of t is equal to integral of some functions f of t and g of t dt. If I try to find out mod y of t, that means we have to take the total modulus here, but that value always less than or equal to integral mod f of t mod g of t. That means if you take the modulus inside the integration, then this is the inequality what we have to use, dt. So from this Squarge inequality, if I use this Squarge inequality here, mod y of t is less than or equal to integral minus infinity to infinity x of t minus tau modulus mod h of tau d tau. This is what we are going to get. And let's take the maximum value for x. That means we are checking whether this value will go to infinity or not. So if I go for the extreme limits, that means if I consider x of t minus tau whose value is equal to maximum, what is the maximum value I can consider? This maximum value is equal to, let's say, m. Maximum value is equal to m. Then this again less than or equal to m constant value integral minus infinity to infinity mod h of tau d tau. So this is what mod y of t. Okay. Now listen carefully. If x of t is the maximum value, that means if it is taken as a finite value, then mod y of t must be less than or equal to n. This is entire thing is nothing but n. So this value should never go to infinity. This value should never go to infinity. That means m value will never become infinity. Only this integral may become infinity. If it becomes infinity, finally this value n becomes infinity. So the system becomes unstable. So now I can say if this integration is not equal to infinity, then we can say mod y of t is satisfying this condition. Then we can say the system is stable. So in conclusion, I can say this integral should never go to infinity. If it goes to infinity, the system becomes unstable. If it is a finite value, then we can say the system is stable. So what is the condition? To get bounded y of t, integral minus infinity to infinity mod h of tau or h of t, I can take change the variable dt less than infinity. So this is the condition what we have to get, so that we can get y of t is a bounded function if x of t is a bounded function. So what is the conclusion we can say? So here this must be integrable. So this factor, what is this factor? Absolute value of h of t. In general we can say mod h of t must be integrable or h of t must be absolutely integrable. So I can say that is h of t must be absolutely integrable. What do you mean by that? What do you mean by integrable first? What do you mean by integrable? Integrable means once we do the integration, that value has to be finite value. If it is not integrable means once you do the integration value, if you get the infinity, the value of the integration is infinity, then it is not integrable. So absolute value is integrable. If absolute value is integrable, then we can say this is nothing but a bounded output we are going to get and the system is stable. So what is the conclusion we can say? If, or we can say integral minus infinity to infinity mod h of t dt is less than infinity, that is h of t must be absolutely integrable. We are not taking h of t, we are taking mod h of t, absolutely integrable. That's what it is. Next, in the similar manner for discrete time case, similarly for a discrete time case, how we can say the system is stable? So for integration, we can go for analogy, that is summation n is equal to minus infinity to infinity mod h of n, mod h of n. If this is less than infinity, this summation value is less than infinity, then we can say the system is stable. That is h of n must be absolutely summable, absolutely summable. That's what the meaning of it, absolutely summable. Okay, take it. Next, condition for invertibility, that means invertible LTI system. Invertible LTI system. So I told you, what do you mean by invertible system? Invertible system means for a system there exists inverse system. For a system, if there exists inverse system, then we can say the system is nothing but invertible system. Now I have defined inverse system. Inverse system must be in a way. So if you cascade system and inverse system, whatever the input you are giving, that is going to be output we are going to get. That's what the meaning of inverse system. That means, suppose if you take a system, let's take, this is a system. For this system, let's take the impulse response is h of t. Suppose if it is having inverse system, if it is having inverse system, inverse system, and let's assume it is having hi of t is the impulse response. Now what did I told you? If the input is x of t, then overall output must be x of t. Overall output must be x of t. So actually, what is the output we are going to get here? Y of t. Y of t is equal to x of t convolution with h of t convolution with hi of t. So to get this value is equal to x of t, what is the condition? Y of t has to be x of t. So what is the condition on h of t convolution with hi of t? This value, whenever this value is equal to impulse function delta t, then we can say this is going to be x of t. So if h of t convolution with hi of t is equal to delta t. So this is the condition on inverse system and systems impulse responses. If system having impulse response h of t and its inverse system having impulse response hi of t, then what is the condition on them? H of t convolution with hi of t must be delta t. Must be delta t. If this condition is satisfied, then the system is having inverse system and this is an invertible system. Clear? Take it. Let me give you the summary what we have done till now, okay, so that you can remember them all at one place. Summary. Summary. Remember, this summary is applicable only for LTI systems. Only for LTI systems. Not any other system. Only for LTI system we are drawing the summary here. Suppose if it is a static system. Static system. What is the condition on h of t? How h of t should be? H of t must be k delta t. For a discrete time case, h of n is equal to k delta n. If impulse response in this form, then we can say that is a static system. Next, second one, causal system. Causal system. What is the condition on causal system? H of t for a continuous time case is equal to 0 for t less than 0, and h of n is equal to 0 for n less than 0. This is the condition it has to satisfy. Next, directly we can write here. No, space is not enough. Let's say third category, stable system. Stable system. For a stable system, what is the condition on h of t? That must be integral minus infinity to infinity mod h of t dt is less than infinity. What do you mean by that? H of t must be absolutely integrable. H of t must be absolutely integrable. Absolutely integrable. This is the condition. Next, fourth one. Sorry, here itself for a discrete time case also we have to write summation n is equal to minus infinity to infinity mod h of n. This value must be less than infinity. That means h of n must be absolutely summable. Absolutely summable. Absolutely summable. That's what the stable system having the conditions. Next, last one, invertible system. For invertible system, h of t and hi of t must satisfy this condition. That is, h of t convolution with hi of t is equal to delta t is equal to delta t, and for a discrete time case, h of n convolution with hi of n has to be delta n. These conditions you have to remember, and remember these are the conditions only for LTI systems. Okay, because for LTI systems only we can go for the convolution, otherwise we cannot go for the convolution also. Take it. So 35. Which of the following represents the impulse response of a causal system? The impulse response of a causal system. Causal system. Option A. Which among the following options causal LTI system will be? Option is B. Option is B. So what did I told you? For a impulse response, if it is a causal system, so impulse response must exist only for positive values of time and it should not exist for negative values of time. So if you observe carefully, this is existing for negative values, this is existing for negative values, this is also existing for negative values. This is the only signal h of t is equal to 0 for t less than 0. If this condition is satisfied, then we can say the system is causal system. Okay, take it. Next, question number 36. H of t is equal to e power alpha t u of t plus e power beta t u of minus t, where alpha and beta are real. Alpha comma beta are real. Then the system is stable. Then the system is stable if options alpha comma beta greater than 0, option B alpha comma beta less than 0, option C alpha less than 0, alpha greater than 0, beta less than 0, option D alpha less than 0 comma beta greater than 0. So this is which option is going to correct if the system is stable. Okay, let's think about it. E power alpha t u of t, e power beta t u of minus t. This represents right-sided exponential, this represents left-sided exponential. So what is the condition on h of t so that the system is stable? I told you h of t must be absolutely integrable. So that means h of t mod h of t, or we can say integral minus infinity to infinity mod h of t dt must be less than infinity. This condition has to be satisfied. Let's say first, if I consider e power alpha t u of t, how it look like? So we may get two things. So it is a right side exponential, means it may be decaying exponential or it may be growing exponential. So it is going to be decaying exponential when alpha less than 0. E power alpha t u of t, this may be like this also. This may be like this also. When this is a possibility, if alpha is greater than 0. If alpha is greater than 0, that is a growing exponential in the right side. In the similar manner, e power beta t u of minus t. How it look like? E power beta t u of minus t. So here also we are having two options, because it is existing only for negative values. So this may be growing exponential. This is going to be growing exponential if beta greater than 0. Next, e power beta t u of minus t. So it may looks like this also. It is a decaying exponential when beta less than 0. So you tell me, if I try to find out area under mod h of t, because it is a real values and positive values, mod won't make any difference. You know, if it is a real and positive h of t, then modulus is not necessary. So simply we have to find out area under h of t curve. So if h of t having e power alpha t u of t like this, then area under this curve is a finite value. But if you consider this wave, so area under this one is a infinite value because it is an unbounded function. Next here, e power beta t u of minus t, in that beta greater than 0 is going to give you the finite area. If beta is less than 0, then this curve is having infinite area under this curve. So where we are getting the finite values for this condition and this condition. That means if alpha less than 0 and beta greater than 0, then we are going to get area under h of t curve is a finite value. So then the system becomes stable. Option D is correct. Take it. If h of n is equal to a power n u of n plus b power n u of minus n minus 1. So the system is stable if the system is stable if. So if you observe carefully, here also it's a right side exponential, it is a left side exponential. So to become area under this one is a finite value. To get the area under this curve is a finite value. That means sum is a finite value. Then it has to be decaying exponential, it has to be growing exponential. So if it is decaying exponential, mod A less than 1, discrete time case, this is the one. Next, mod B must be greater than 1. In the discrete time case, we have seen when it is going to be growing, when it is going to be decaying. So these are the conditions what we can say. Yes, this is the way. Take it. Question number 37. H of n is equal to 2 power n u of n minus 2. So what is the system nature? They have given options: causal and unstable. Option B, non-causal and stable. Option C, causal and stable. Option D, non-causal and unstable. So you tell me which option is going to be the correct one. For this h of n, means the system is having impulse response like this, then which one is the correct answer? Okay. First, whether it is a causal or non-causal. What did I told you? If it is a causal system, h of n has to be 0 for n less than 0. If you observe carefully, u of n minus 2. U of n minus 2 means it is existing from 2 to infinity. It is existing from 2 to infinity. So h of n has to be 0 for n less than 2. That's what the meaning of it. So for n less than 2, the values are 0. That means h of n has to be 0 for n less than 0 also. So that's what the meaning of it. So h of n exists from 2 n is equal to 2 to n is equal to infinity. That is, h of n is equal to 0 for n less than 0. So that means the system is causal. That implies causal system. causal system. Next, we have to say whether it is stable or not. To say whether it is stable or not, what we have to calculate? Summation n is equal to minus infinity to infinity mod h of n. That's what we have to calculate. So if I calculate this one, so let's say because it is existing only from 2 to infinity, if I take the limits 2 to infinity 2 power n, modulus won't make any difference because it is not a negative, it is not a complex. So this is nothing but 2 square, 2 cube plus and so on 2 power infinity. This value is infinity. So we got this one is not absolutely integrable because it is became infinity. So whenever it becomes infinity, the system becomes unstable. The system becomes unstable. So it is a causal and unstable system. Option A is correct. Take it. Let's take this example. H of t is equal to sin t. Now, first we have to check whether it is static or dynamic. Static or dynamic. Second one, whether it is causal or non-causal. Third one, whether it is stable or unstable. These things we have to check. Stable or unstable. These things we have to check. Okay, let's see one by one. So many people think that it is a dynamic system. Absolutely wrong. See, what you are checking, sir, you may say, sir, sin t curve is existing from minus infinity to infinity, so it is taking the past values. So that is not the things what we have to consider. What we have to consider is, I already told you what is the condition on h of t so that the system can be said as static system. So simply we have to observe whether it is k delta t or not. That's the only thing we have to observe. So to say whether it is a static system or not, only one thing we have to observe. What is that? Whether h of t is equal to k delta t or not. If it is k delta t, we can say it is a static system. If it is not, then we can say it is a dynamic system. Yes, it is not k delta t, it is sin t. So I can say h of t is not equal to k delta t. Then it is a dynamic system. Next, whether it is a causal system or non-causal system. If you take h of t, how it look like? Which is existing from minus infinity to plus infinity. If it is existing for negative values of time, that means h of t is not equal to 0 for t less than 0, is not equal to 0 for t less than 0, then the system is non-causal. Next, is it a stable or unstable? So many people will say answer is stable. What you thinking is, I am telling you what you are thinking, but it is definitely a wrong thinking. Why? So you may think that, sir, if I do the integration area under this curve, whatever it is positive, there is a negative area, so they get cancel each other. Finally, I can get a 0. That means h of t is a sin t curve, right? What is the area under sin t curve if I take minus infinity to plus infinity? Because it is an odd term. Sin t is an odd signal. If I integrate from minus infinity to infinity, you may get 0. So 0 is not an infinite value, so it is a stable system. That's what you are thinking, but it is not the correct way. Why? First of all, it is not about h of t. I told you, to say whether the stable system or not, we have to consider mod h of t, not h of t. So if I consider mod h of t, that is mod sin t. What do you mean by mod sin t? That means even if you are having the negative, we have to take them as positive. So positive is positive only, and this negative portion will become again positive. Negative portion will become again positive, like that. It will go here. again. So this will go up to infinity at infinity. Now, what is the area under this curve? In this case, it is definitely infinity. Why? Suppose if I take one single pulse, so it is having some finite area. Like that pulses, how many pulses we are having from minus infinity to plus infinity? Infinite pulses. So area under one pulse is a finite value. Like that pulses we are having infinite. So what is the total area? Which is nothing but infinity. So integral mod h of t from minus infinity to infinity is equal to infinity. Is equal to infinity. So the system is unstable. Okay, take it. Example, true or false question. Let's see. If the impulse response of an LTI system is periodic, then it is always non-causal and unstable. Non-causal and unstable. So true or false? True or false? Which one is correct? Is it true or false? It is true. It is definitely true. Why? If impulse response of an LTI system is periodic, so just we have seen one example, sin t, which is nothing but a periodic signal. So if it is a periodic signal, it is definitely existing from minus infinity to plus infinity. So definitely the system becomes non-causal. That's one way. Next, what about whether it is a stable or unstable? So if you take the modulus of a periodic signal, definitely everything will go to what we can say positive value. If it is a positive value, if you try to find out area under this curve, definitely that is going to be infinity. So I can say yes, if impulse response is periodic, then it is always non-causal and unstable. It's a true only. Okay, take it.